When you design and implement a backtest, it is important that you have a clear idea of what you want the backtest to accomplish. Your goal at the initial development stage is to set up a strategy pipeline and then filter out any strategies that don't meet your minimum performance criteria. Backtesting provides an efficient filtration mechanism so that you can eliminate weak strategies that have a low risk-adjusted return or that have large anticipated drawdowns. You can use Sharpe ratios and Kalmar ratios to rank your strategies, but keep in mind that risk and drawdown may be higher when you move to a live trading strategy. Backtesting also allows you to test your model and fine-tune without risking trading capital. It helps you to identify microstructure issues early on, such as transactions costs, liquidity, and latency in data and order execution. Backtesting provides a framework in which you can optimize your strategy by modifying the quantities or values of the parameters associated with that strategy and then recalculating its performance. Unfortunately, by optimizing your strategy, you run the risk of introducing overfitting bias into your model, which we'll talk about a bit later. So far, you've gotten a good idea of all of the benefits you can get from backtesting your model. Now we will talk about some of the traps that many quantitative strategy developers fall into when backtesting their models. Models depend on correlations which can vary or even reverse given enough time. Backtesting takes the correlation in the test data series as a given. At a minimum, you should measure the value and variability of critical correlations over your entire data set. Data can be incomplete or contain fictitious outliers. You need to carefully cleanse your data before using it in a backtest. You also need to decide if the frequency of data that you have available is sufficient to test your strategy. For long-term strategies, open, high, low, and closed data may be sufficient. For high-frequency strategies, you need tick-by-tick data and visibility into the order book. Slippage is the difference between the last market bid or offer and the price you actually buy or sell at. Your model needs to factor in getting somewhat worse prices, especially in volatile markets when using market orders. You also need to model realistic market impact cost. It's not realistic to assume that you'll be transacting at the midpoint between the bid and the ask price. This is especially critical in markets with limited or variable liquidity. It is easy to allow biases to weaken your backtesting model and strategy. One bias that we've already mentioned is overfitting your model to a limited data set. This makes your model perfect for the backtest data, but also very likely to have completely different performance when tested in a live market. Look-ahead bias sneaks into your model whenever you inadvertently include data outside of your testing window. This can happen when you tweak factors and correlations to reflect more recent data. Survivorship bias occurs when you use data sets that don't include the stocks of companies that have either gone out of business or been merged into another company. This is when you are backtesting your strategy on a number of different stocks that have all survived to the present and so represent a positively skewed sample. Drawdown tolerance bias is a common feature of discretionary trading, but is mostly ignored for quantitative trading. When you create a backtest that covers a period of 5 years or more, it is easy to look at an upward trending equity or equity index price curve, calculate the return, Sharpe ratio, and drawdown characteristics, and be completely comfortable with the risk you're taking. The strategy might have a maximum drawdown of 25% and a maximum drawdown duration of 3 months. This would not be unusual for a momentum strategy, and it's easy to convince yourself that you can tolerate these losses because the return potential is so good. In practice, a drawdown of 25% extended over 3 months would raise some serious doubts in your mind about the strategy. Your funders would probably intervene and pressure you to end the strategy and take a loss. Now we look at the difference between backtests you create in the development phase and those that you use to retest strategies that are candidates for full implementation. You design development backtesters to help create many preliminary models. So strategies with varying sets of parameters can be tested quickly and either discarded or qualified for a more thorough implementation backtest. They are used to identify statistical relationships and market behaviors that have the potential to be exploited in a quant strategy. One big weakness is they tend to give inflated performance as they don't consider the full costs of strategies. You can use R or Pandas to code development testers, and it's generally simpler to code these than to code an implementation backtester. Implementation backtesters are more difficult to code because they simulate all aspects of a strategy going live. Implementation backtesters require a data interface to handle both historic and live market data, a quant strategy that generates signals to a portfolio manager that then creates orders and measures performance, and then an order execution handler that sends orders and receives confirmations.